Hey there, AP friends. Here's some more examples that we can look at that's related to the implicit differentiation that we're learning right now in AP Calc. Okay, these are the kind of examples that we'll see a little bit more along the lines of the AP exams. They're a little bit trickier, but try to look for and underline the really important clue words here. For example, we're trying to find here in the first example, can you find the equations of both the tangent and the normal lines to this graph here? When you look at this graph, do you notice right away that it looks strange? And why does it look strange? Because the y's are buried inside. And when the y's are buried inside, your brain thinks, I have to do implicit. When I take the derivative, I have to do it implicitly with the dy, dx, or y primes. And we're given this point here to help us out. All right, so it's the same steps as before. Find the equation of the tangent and normal lines. So we should find the slope, which means we should find the derivative, which means we need to do it implicitly. So let's just go left to right, and as I go left to right, just take the derivative with respect to x. Here we go. The first time, we should get 3x squared is the derivative of x cubed, plus, okay, the derivative of a y term. There we go. First of all, I know it's going to be just 3y squared because it's a variable, but because it's y, remember we have to multiply by the derivative of y. And again, you can either put y prime or you can put dy dx. I'll put y prime, but I'll put it in red so I can see it really clearly. Okay, that term itself is done. Equals, all right, well, I have a 2 here hanging out. So I'm going to put the 2 on the outside and just focus doing on the derivative of the inside. Ooh, but on the inside, do you notice here we have a product? So we're going to need product rule with the y term as well. So how about I do that off to the side here as my brain's thinking about it? The derivative of x times y by product rule should be, should be the derivative of x times, leave the y alone, plus leave the x alone, and multiply by the derivative of y, which I'll put in my other red color. And the derivative of x is just 1, right? So this becomes 1 times y, or just y, plus x, y prime. Okay, why don't we plug that back in here? So here we go, folks. From the left, we have 3x squared plus 3y squared times y prime equals 2 times, and then what we're going to plug back in, y plus x, y prime. Great. Okay, now in order to find the slope, remember that y prime is not only the derivative, but y prime also means the slope. So we need to solve for y prime in order to find the slope. But do we really? This is one of those questions again where we're at crossroads. I'm going to put a little star. What do you choose? Would you rather, here's the best would you rather game. Would you rather solve this for y prime? It's a little messy, but you could do it. And then, of course, in order to find what the actual slope value is, you're going to plug in your x and y. And then that will give you your slope. Okay, that's one path. Or another path is, what if you just do it in different order? Instead of doing algebra, what if you plug in 1, 1 right now? Would that be okay? It would make less variables to look at. It would make less pure variable algebra. But then we would have to still solve for y prime. But maybe would it just be easier because it's only one variable now and not a whole bunch like the other way? And then once you get y prime, that would be your m. So you choose which way is best for you. Most people will tend to do the right-hand side because there's less variables when you plug in right away. And then when you solve, it is a little bit easier. But both steps are fine, whichever way you like. I am actually going to do the right-hand side. I'm actually going to plug in right now, and then I'll solve for y prime. But if you want to do it the left side way, that's fine too. Just see if we match up and get the same slope value. All right, so I'm going to plug in 1, 1 for all of these x's and y's. I'm going to leave the y primes alone because that's what we don't know. All right, 1, 1. So we get 3 times the x value is 1. The y value is 1. The y value is 1. The x value is 1. Okay. And now the only variable, as you can see there in red, that we have to solve for is y prime. And I think this is just a little bit easier because there's just numbers and the y prime, that's it. Okay, 3 times 1 squared, 3 times 1 squared. Inside this parentheses, I have basically 1 plus y prime. So if I multiply that out and distribute, I should get 2 plus 2y prime. Okay, let's gather all of our y primes together. So I'm just going to move some furniture around, and I should get, once I subtract, y prime on the left should equal -1. Great. Okay, so that is my slope. Y prime, which is the derivative, when I plugged in the value, is my slope value. Great. And we already have the point of 1, 1, so I feel like we can do the tangent line right now. Shall we do it? Here we go. Ready? Y minus the y value equals slope x minus x value. There we go. That's the tangent line equation. Great job. Now, in order to find the normal, we basically take the same steps, but we're going to take our slope here, and we need to do what we call the flopposites. So if your tangent slope was -1 or -1/1, then your normal slope should be, you flip it over and you take the opposite sign, which is +1. Okay, so here we go. We got our point still. So y minus your y value equals now just the slope of 1, x minus the x value. Or if you want to, you can just leave the 1 by itself and just say y minus 1 equals just x minus 1. Both these answers are fine. But this would be the solution of the normal line equation. Okay, folks? So the practice on this one was really to show, can you do the implicit differentiation here? And then this was a really important question. Would you rather, when you do these on the AP exam, would you rather solve for the y prime, do a little bit more algebra, and then when you plug in, it's actually a little bit easier in that sense because the variable is already solved for us, you just plug in. Or would you rather choose this other side where you plug in the value first, less variables to solve for and isolate, and then solve that way? Up to you. All right, one more problem that you can try. Another really good one. Can you find all the points on this graph? Do you see all the y's buried in there? So I'm going to need implicit differentiation if I need to find the derivative. Does anyone know what that equation is? I've got some squared terms, some not so squared terms, some constants. There's a plus sign. This comes from conics from Algebra 2 days, if you remember that, many years ago. The plus sign says it could be either a circle or it could be an ellipse, but because the coefficients are different, this is actually the shape of an ellipse. Pretty neat. And I'll show you a graph for that a little bit later. But the question says, can you find all the points? And a little clue here, when you see the word points, that's just not x, they would say x values, but points means I need to find the x and the y's, where this graph has vertical and horizontal tangent lines. Okay, what does that mean in calculus? Remember, if you have a vertical tangent line versus a horizontal, I feel like we've seen horizontals a lot. If there's a horizontal tangent line, what do you know about the slope of that? Ah, it's 0, right? Remember, another word for slope is the derivative of y. So the derivative should equal 0. So maybe we should find the derivative and set the derivative equal to 0. How about vertical? Vertical tangent lines don't have any slope. It's undefined, right? So how do I do that? Well, we know it's undefined, but what does that mean in terms of y? I don't know. We'll come back to that later. But why don't we go ahead and take the first step, and why don't we take the derivative of our big equation up here? The y is buried in there, so we're going to need implicit. If you feel like you want to start this on your own, folks, take your time, do it on your own, and take either path. Would you rather, would you rather? And then, well, actually on this one, sorry, you can't plug in points. We don't have any values to plug in. We're solving for the points, actually, Mr. Brown. We do need to solve for y prime, so you have to do a little bit of algebra. All right, why don't you pause the video, folks, try it on your own, and check back and see if we match up. See you soon, and good luck. Okay, are you ready, folks? Here we go. Let's just go, again, left to right, and just take derivatives. And if you ever touch a y term, or the y variable, you must include y prime by the implicit chain rule. So x squared becomes 4y squared. By power rule, becomes But because of implicit and chain, we need to multiply by. And again, if you'd like to use dy dx instead of y prime, that's fine too, friends. Now this is 16, but again, because of the chain rule and implicit, I have to multiply by the derivative of y itself. The derivative of 4 is just, and then don't forget the right side because we are in an equation, derivative of 0 is just 0. Okay, so look at all those y primes. Notice that we also have x's and y's, but the best thing to do is to take all your y primes like before, and can we get them on the same side? Let's see, let's identify. This guy's got a y prime, this guy's got a y prime, so let's keep them on this side. Anything else we're going to toss over to the right side. Okay, when I toss things over, the 4 becomes positive, and the 2x becomes negative. I think those are the only non-y prime terms. Okay, and like we did before, in order to get the y prime by itself, why don't we factor it out first, like a GCF? And then finally, to go ahead and solve for y prime, the derivative, let's just divide that parentheses from both sides. That makes a fraction, and that's very, very popular in differential implicit differentiation. Okay, that looks great. Now, actually, I do see there is a 2 everywhere, so if I divide every single term by a 2, that would be legal, because every term does have it. So that would be fine. But there's not much else I think I can do. Okay, there's my derivative. Now let's go back to the actual question. Ready? It says, can you find the points x and y where the slope is 0, where you have a horizontal tangent line? Let's do that one first. So that means where is the derivative y prime equal to 0? Okay, friends, remember in general math, when a fraction equals 0, what part really equals 0? The top, the bottom, both? If you think about it, it's only when the top equals 0. When the top of a fraction equals 0, then that means the whole fraction equals 0. So you really just need to focus on where does 2 minus x equal 0. And that happens when x equals 2. Great. Okay, so I know at the point 2 comma something, I have horizontal tangent lines. But, like, what are the y values? How do we find the y values? Because I think that's on the original graph. That's not on the derivatives. I don't want to plug it back into the derivative. I think I want to plug it back into the original because it's on the original graph over here, right? Okay, so when we take the original graph, we'll plug in 2 for x and we'll see if we can solve for y. Okay, ready? So I need 2, let's see if I have enough space for this. I think I can do it. I'm going to say, make some room over here. Let's say when x is 2, I get 2 squared plus 4y squared. I don't know why. I'm going to solve for it. Minus 4 times 2 plus 16y plus 4 equals 0. Okay, let me simplify that. 4 plus 4y squared minus 8 plus 16y plus 4 equals 0. Okay, this is just normal algebra. Let's gather all our y's together. We have a y squared. We have a regular y. How about the non-y's? Let's see. Well, I've got 4 and a minus 8. That's just 0. Oh, there we go. Oop, I had to put a 16y there, Mr. Brown. Okay, we got to solve this, friend, which means we need to probably factor it because it's a quadratic. And it's only 2 terms, so maybe we can just look for a regular GCF of 4y. Let's factor out 4y. I should get a y plus 4. That means my y values from the first term, 4y equals 0 and y equals 0. Y plus 4 equals 0 and y equals negative 4. I got 2 places. That's going to be interesting. It kind of makes sense if you think about it for a second because remember we said up here on top, this is an ellipse. So ellipse has curves on top and bottom and left and right, so maybe that makes sense. But we'll come back to that in a second. All right, so it seems like for when x is 2, I get 2 answers. I get 2 comma 1 y value and 2 comma the other y value. That's when I have a horizontal tangent line. That's one answer. Well done. Well done. Let's figure out where this one has the verticals. Okay. Well, we know that y prime is this, friend. And we need to find out where is this. This is the derivative. This is the slope. Where is this undefined? And again, let's think about when is a fraction ever undefined? What do we do in math that gives us an undefined answer? And that's when the denominator equals 0. Ooh, that's interesting. So we did the numerator equals 0 for the horizontal tangent line, sorry. We're going to do the denominator equals 0 for the vertical tangent lines. All right, why don't we solve that, guys? So where is the denominator equal to 0? That would be when y equals -2. Great. Okay, but now what are the corresponding x values that go with that? How am I going to find that out? That's on the original graph, right? Okay, I think I need to go back and plug it back in the original. All right, so I'm going to save some space here. And let me just erase some of my work here so I can see it better. Okay, pardon me, excuse me, coming through. Hopefully you have all this work down in your notes already, so you're good to go. Okay, we found that our y value was -2, is that right? Yeah, it is. So why don't we plug -2 back into the original over here. There's all this stuff going on over here. All right. So now y is -2. On the original, let's see, I get x squared plus 4 times y is -2, and so on and so on. Okay, all we have left are x's, so I'll gather x's, but let's simplify a little bit first. We have looks like another quadratic, right? With the x squares and the x's. Let's gather them all on the same side. That looks about right. All right, this actually factors very beautiful, I think. Let's see. Two numbers to multiply to give you -12 and add to give you -4. Works like that. So my x's corresponding would be +6 from there and -2 from there. So now the question is asking, where is it vertical? I will have vertical tangent lines at the points x, comma, the y that we found, and x, comma, the y that we found. Did we solve it? Let's double check. We found the points, check, where it's vertical, got that. Denominator of the slope equals 0, and horizontal, where the numerator. Now remember those points. Ready? Here's your ellipse. That's the graph of that problem. Can you look and see right now, where are there horizontal tangent lines? If you were to draw that here, could you find them? See right here on the top? Where does it hit? At 2, 0, right? How about here on the bottom? Where's it hit? Add 2, -4. Isn't that what we said? Look at that. Right here, 2, 0, and 2, -4, the horizontals. Shall we check the verticals? Can you see on here, where would the vertical tangent lines be? If I draw a tangent line, where would it be? Up and down vertical? And that would be right here on the ends. What point is that over here? Okay, that looks like 1, 2, 3, 4, 5, 6, -2. Okay. How about way over here on the left side? Right there, another vertical tangent line, undefined slope. That would be at -2, -2. 6, -2, and -2, -2. Will you look at that? Math is beautiful. So there you go, folks. There's two really good examples of how you can use implicit differentiation with the chain rule to solve some of these tougher problems. Great work today, folks. I'll see you next time.